This video is from the prerequisite chapter, P.7. It's all about complex numbers. What about powers of I? Well, we already said that the square root of -1 is I. That's the ultimate complex or imaginary number. We also already said that if you were to square that, you would just get -1. Because if you square both sides of this, the square and the square root cancel. So you're left with -1. Well, what if you were to cube I? What happens in that case? Can we say that I cubed is I squared times I? It is, right? So is I squared -1? And I is just I. So what's -1 times I? It's -I. So I cubed is really the same thing as -I. Now remember, if this gets confusing, pause it, rewind it, and listen to it again, because you really need to get this. How about I to the 4th? Could I say that I to the 4th is the same as I squared times I squared? Okay, but I squared is -1. So that's the same as -1 times -1, which is +1. So I to the 4th is the same thing as +1. Interesting. How about I to the 5th? Could I say that's I to the 4th times I? What's I to the 4th? It's 1. So we get 1 times I, which is just I. So I to the 5th is the same thing as I? Oh my goodness. Okay, how about I to the 6th? That's I to the 4th times I squared. But what is I to the 4th? I to the 4th is 1. And what's I squared? I squared is -1. So we get -1. So I to the 6th is actually -1. How about I to the 7th? Can I say that I to the 4th times I cubed? What's I to the 4th? I to the 4th is 1. What's I cubed? I cubed is -I. 1 times -I is actually -I. Okay, last one. I to the 8th. Can I say that's I to the 4th times I to the 4th? But what's I to the 4th? I to the 4th is 1. And 1 times 1 is 1. So what exactly is going on here? We started with I, then we got -1. Then we got -I, then we got 1. I, -1, -I, 1. Do you see a pattern forming here? I, -1, -I, 1. I, -1, -I, 1. That pattern will continue to repeat forever and ever and ever, as long as these exponents keep increasing by 1. So really all you have to do is remember these first 4. Now if you'll notice, for every one of these after I to the 4th, I started with I to the 4th. Why would I do that? That's because I to the 4th is 1. So if I can find out how many I to the 4ths there are, I can just throw all those away because we're multiplying by 1. Let me show you what I mean. Let's say we have I to the 25th power. That's the same thing as I to the 4th. How many 4s are there in 25? There are 6 of them, right? I to the 4th to the 6th is actually I to the 24th, which means I need 1 more I. Wouldn't this be the same thing as I to the 25th? Okay, so what's I to the fourth? I to the fourth is 1. What's 1 to the 6th power? It's 1. What's 1 times I? It's I. So I to the 25th power is the same thing as just I. So let's review what I just did. Right here, we find out how many I to the fourths there are in I to whatever exponent we have. So how many 4s are there in 25? There are 6 of them, but we do have a remainder. I to the 4th to the 6th is I to the 24th, which means I need 1 more I to make I to the 25th. That's how I come up with this one. So let's try another one. I to the 83rd power. How many 4s are there in 83? We can divide it on our calculator. 83 divided by 4, we get 20 and something. So we're going to say that there are I to the 4th to the 20th power. Well, that's only I to the 80th. How many more do I need to make 83? I need 3 more. Well, I to the 4th is 1. 1 to the 20th is 1. So we just get I cubed. But what is I cubed? I cubed is negative I. So I to the 83rd power is the same thing as negative I. So what if you're going to divide complex numbers? Remember that whenever you divide or you have radicals and fractions like 1 over the square root of 2, it wouldn't be simplified if you leave it this way. And if you remember from that section, we would just multiply this by the square root of 2 over the square root of 2. We would end up with the square root of 2 over the square root of 4, which ends up being the square root of 2 over 2. That's called rationalizing the denominator. Well, you have to do the same thing if you have an I in the denominator, because I is a square root. So that takes us back to conjugates. I know we talked about that in the previous section. Remember, conjugates just mean you switch these two signs. What happens when you multiply complex conjugates? Remember, if it has an imaginary part, then it's called a complex number. Well, let's see. Multiply 4 minus 2i and its conjugate. So 4 minus 2i times 4 plus 2i. 4 times 4 is 16. 4 times 2i is 8i. Negative 2i times 4 is negative 8i. And negative 2i times 2i is negative 4i squared. What happens to these two middle terms? 8i minus 8i is 0. So we have 16 minus 4 times, what's I squared? It's negative 1. So you end up with 16 plus 4, or 20. So whenever you multiply complex conjugates, you get rid of all the imaginary parts. That's pretty cool, right? Okay, when you simplify a fraction, you're not allowed to leave a radical in the denominator. That's what we were reviewing up here. If you multiply something, if you multiply something by 1, is what that's supposed to say. If you multiply something by 1, do you change that something? Example, 5 times 1 is just 5. So when we multiply by 1, we're not changing it, right? Okay. Well, at this example at the bottom of the page, we want to multiply this by 1, but it has to be in the form of the denominator. Notice how this is only one term. If it's just one term, we don't have to worry about the conjugate. If you multiply these two, 2 times I is 2i times I is I squared. But what's I squared? I squared is negative 1, and 2i over negative 1 is negative 2i. So as long as you get the I out of the denominator, you have rationalized the denominator.